Good morning. So today we're going to look at solving log equations. There's going to be two different ways to solve log equations. So the first way, just like with an exponential, we're going to have log on both sides of the equation. Okay, so the first thing that we need to do is condense or combine our logs. So condense each side. So there's one log there. Now that if the logs are the same on both sides, and then the base is the same, on both sides, so both of those bases are the same, then you can set whatever's inside there equal to each other. Okay? And then once you set them equal to each other, then you can solve. So just like with the exponential, if they're the same base on both sides, then you just set the exponents equal to each other. So here, if whatever's inside this base log here, if these logs base b are the same, then you can set what's inside there, what's inside each of them equal to each other. Okay, and then remember, just like with an exponential, we'll have to check our solutions. Okay. Okay, so with this one, I have log base 2 of 1 minus 4x is equal to log base 2 of 2x plus 43. So my logs here are the same, right? There's one single one on the left and there's one single one on the right. So I'm going to be able to set what's inside there equal to each other. Okay, so now this is just a linear equation, right? So you'll get 1 minus a 6x is equal to a 43. Subtract 1. So negative 6x is equal to a 42. And then divide both sides by negative 6. So x is going to be equal to a negative 7. Right? But check it and make sure that's okay. So when I plug in, basically what you're checking for is you can't have a negative inside the log. Right? So if you were to plug it in right here, so 1 minus 4 times a negative 7, that would actually turn into a positive number there. 2 times a negative 7 plus the 43, that's not a negative number either. So we're good. We are good with both of those. Okay? So let's solve. Y'all do this one for me. So log base 9 of of 6 minus 3x is equal to log base 9 of negative 2x. So y'all take a minute and try to do this one for me. Okay, so these are one single log on the left, one single log on the right, so I can set what's inside there equal to each other, and then I can solve. So I'm going to add 3x to both sides here. So you'll have a 6 is equal to an x, or let's just say x is equal to a 6. Okay, but remember we need to check and just make sure right here, this is a negative 2 times 6, so that's going to give you a negative number inside there. And then same thing right here, 6 minus 3 times 6, that's also going to give you, this is going to give you a negative number, this is going to be a negative number. So really, this is going to be no solution. Even though you found a number, you have to go back in there and make sure that it doesn't give you something that doesn't make sense. So basically, you can never raise 9 to a power to give you a negative number. Okay, so do I have a single log on the left and a single log on the right? No. So the first thing I need to do before I do anything is combine. And I have a plus sign inside in between those two logs. So plus sign means to multiply. So this is going to be log 4 times y plus 5. It's multiplication, right? Is equal to log, so we're using our properties to get one log. So now I've condensed it, and I have a log on the left, and I have a log on the right. So I'm going to be able to set what's inside there equal to each other. Okay. So we'll solve. So 4y plus 820 is equal to a 72. We will subtract 20 on both sides. So I'll get 4y is equal to a 52, and then divide both sides by 4. So y is going to be equal to a 13. So if you look, does that make sense? So if I plug in a 13 anywhere, that's good, right? The only place you really plug it in is right there. So that's okay. So we're good with that one. Okay. So y'all do this one for me. Okay, so I need to, before I do anything, combine these logs, and that's a minus sign. So this is going to be log base 4 of 68 divided by a 4 is equal to log base 4 of 3x plus an 11. Okay, so now that we've got one single log on the left one single log on the right. I'm going to set what's inside there equal to each other. So 68 divided by 4 is going to be equal to 3x plus an 11. 68 divided by 4 can divide, so that is going to be a 17. So subtract 11. So that's going to be a 6 is going to be equal to 3x. Divide both sides by 3. So x is going to be equal to a 2. Just go back in there and make sure. So 3 times 2 plus an 11, and we are good. Okay? All right, I'll do one more. Okay, so before I do anything, I need to combine by using my property. So this is going to be log of 2x times an x, right? Because the plus sign inside there means multiplication. I don't need to do anything to the right hand side. So now, since I have logs on both sides, I can set what's inside there equal to each other. So 2x times x is actually 2x squared is equal to x squared plus a 16. So now I would solve. So subtract your x squared on both sides. So you're going to get an x squared is equal to 16. And what can I do? Remember, we could use the square root property here. And so this would be x is going to be equal to a plus and a minus 4. Those are my answers. Right? But what happens when you plug in a negative 4 right here? It's going to give you a negative answer inside there. So negative 4 is not going to be a solution. So my only solution is going to be a positive 4. Okay? So we throw the negative 4 out because negative 4, like I said right here, negative 4 makes inside there negative. So throw that one out. Okay? All right. So the other type of log equation is when, so here's the second one. Okay, so this is where you have a log on one side and it's going to be equal to a number. Okay. So, same thing, you're going to condense the left side to a single log. Okay, and now that you have a single log is going to be equal to some number, well, I guess I'll change that to, let's call that A. Okay, so you're going to rewrite this. So rewrite as an exponential. Remember? So this is going to be base B raised to the a power is going to be equal to what's inside there, your x. Okay? And just like with the other one, you will check your solutions. Okay? Alright, so let's look here. So if I wanted to solve log base 2 of x minus 4 is equal to a 6. That is a 2. I'm sorry, that looked kind of funny. Okay, so I've got a log just on one side. So when I have that, okay, so when I have that, I'm going to change this to an exponential. So this is going to be 2 raised to the 6th power is going to be equal to what's inside there, x minus a 4. So 2 raised to the 6th power is going to be a 64. So now you'll just solve. So you'll add 4 to both sides. So you'll have 68 is going to be equal to an x. And if you were to plug that in there, that number, 68 minus 4, that's going to give you a positive number inside there. So we're good. Okay. So I do not have a single log. So I don't have a single log, and I've got numbers in front. So first thing I need to use my rules to condense. So this is going to be log of x squared minus log of 4 is going to be equal to a 2. I still need to combine by your subtraction, so you'll divide. So this will be log of x squared over 4 is equal to a 2. Okay, so now you have a single log on the left. Okay, remember when it's log and there's no base there, it's an understood what? 10. So understood base 10. So this is going to be 10 raised to the 2nd power is going to be equal to what's inside there, which it's an x squared over a 4, which is kind of crazy. So 10 squared is a 100, and then multiply by 4, so that'll be a 400 is equal to an x squared. Then you can take the square root of both sides, so the square root of 400 is going to be a plus and minus 20. So if you were to plug in the negative version right there, that's not going to work. So my only answer is going to be the positive 20. Okay? All right, y'all do this one for me. Okay, first things first, I need to condense, right? There's a plus sign there, so that means multiplication. So I need to combine and say log of x minus 3 times x is going to be equal to a 1. So now that I have this log here, I can rewrite as an exponential. So remember, here there's no base, so the base isn't understood 10. So this is going to be 10 raised to the first power is going to be equal to x times x minus a 3. So this is going to be 10 is going to be equal to x squared minus a 3x. So now I'm going to have to solve this one by factoring. So this is going to be a 0 is equal to x squared minus a 3x minus a 10. So now I need to factor what multiplies together to give me a negative 10 and adds together to give me a negative 3. So that's going to be a minus a 5 and a positive 2. So I set both of those equal to a 0. Okay. Well, the negative version here, the negative 2 right there, is going to cause something inside there to be a negative. So my only answer is going to be a 5. Okay? Alright, so start working on your homework, and tomorrow we'll review a little bit and talk a little bit more about log functions, okay, and exponentials, kind of doing some exponentials and logs, solving some together. Okay, alright, y'all have a great day.